to be a genius, you've got to be crazy. You've got to be crazy because you have to back a new idea at a time when there isn't enough evidence.
Is our current academic system actively suppressing the next Freeman Dyson or Newton? What does current academic system even mean? Today, we're joined by Gregory Chaitin, a mathematician and a computer scientist who published his first groundbreaking paper at 15 and went on to become one of the founders of algorithmic information theory. He believes we're in a crisis of innovation. Chaitin argues that modern academia is suffocating scientific creativity. We've spoken to Gregory Chaitin before about his inventive work in metabiology and algorithmic complexity, but today we're diving into even deeper waters of his perspective at the prestigious Institute for Advanced Studies. Chaitin pulls no punches in diagnosing what he sees as a terminal illness in how we pursue scientific knowledge. It's not science that's wrong, it's how it's being squelched and distorted in the modern university system. Gregory, let's talk about contradictions in mathematics.
Contradictions in mathematics are nothing new. Cantor's theory of infinite sets was full of contradictions. Bertrand Russell, before he wrote the Principia Mathematica with Whitehead in an attempt to give mathematics a more secure foundation, kept writing about different paradoxes and contradictions in mathematics, which is why he proposed to use logic as a basis for mathematics. And that was the reason that Hilbert said the salvation of mathematics will be formal axiomatic systems that you can analyze from the outside metamathematically and show that they don't lead to contradictions and that they're complete, that they enable you to prove everything that is true. Unfortunately, it turns out you can't do that for all of math, right, due to Gödel's incompleteness theorems. But Gödel's incompleteness theorem doesn't show that mathematics is contradictory. What it shows is that no very safe formalization of mathematics will be complete. But in fact, in practice, it's good software engineering now. Mathematicians are coming up with proof checkers that they use in their actual mathematical research. And these, like Lean, I think is the name of one of them, these are actually like formal systems that have been engineered in a way that they can be used by working mathematicians to check the work they're doing. So I think that if you're going to say that mathematics is dying because there are contradictions, if you want to attack pure mathematics, there are easier ways to do it. For example, you can say 1, 2, 3, 4, 5, 6, 7 to infinity. You don't believe in that. Who's going to see an infinite set?
Well, I think that's what Joscha Bach does. Joscha Bach and other computationalists they generally tend to be finitists as well.
Yeah, well, it's possible the physical universe is finite, but the mathematical universe is definitely infinite. Now, where is the mathematical universe? You may say it's in the mind of the mathematician, or you may believe that it has some kind of reality in a Platonic world, and that the physical world perhaps is built out of math, out of this Platonic world. These are all fundamental issues in philosophy. But finitists, when I was a young student, there were constructivists who wanted all of mathematics to be done with existence proofs that were constructed. They didn't want you to prove something by assuming that it's not the case and then deriving a contradiction. And that's a very common strategy in pure mathematics. It can be brilliantly applied in many cases. And Eric Bishop was one of the people who worked on this. And then with the computers, there's a big incentive for constructive proofs, because it's nice if you say that a partial differential equation has a solution and you prove it by assuming it doesn't and getting a contradiction, that doesn't help you to find the solution. So people with computers who want to actually calculate the solutions are essentially doing constructive proofs of existence rather than reductio ad absurdum proofs. And but it's still the case, the kind of mathematics I do deals with things that you can't calculate. A constructivist will say the halting probability doesn't exist because you can't calculate it. But that's precisely why it's interesting, because you can't calculate it. But you can say it doesn't exist. Okay, it's like a flying horse, if you like. It's a mythological object.
Yes, like there's plenty of fiction that's interesting, but we're trying to describe the non-fictional world, the actual world.
Right. When you're doing conceptual work, you can sort of choose the world. In mathematics, you can sort of create the world you want to work in, want to do research in. You sort of postulate and create a situation that then you explore. Now, which some mathematicians say, well, that means we're more fortunate than physicists who have to worry about the physical world, which may not be as beautiful as imagined worlds. But in fact, with superstring theory, the physicists don't care anymore about whether it applies to this world. 22 dimensions, remember all of that?
26, yeah.
And it's certainly beautiful mathematics, whether it's physics. I knew a guy, Brian Greene. I helped him to get a summer job at IBM because people told me he was brilliant, and he was. And when I heard that he had gotten a professorship at Columbia, it was described to me like this. It was a joint professorship between the physics and the math department, because the math department thought what he was doing was physics, and the physics department thought that he was doing was math. And the answer is, it's neither.
Interesting.
Brian Greene, superstring theory. Well, anyway, he's published books on that topic.
Yes, I've spoken to him on the podcast.
Yeah, he has what does he call it? The World Science Fair or something in New York?
Correct.
That he and his partner, who is from the TV world, organized. They had me on a panel once with Marvin Minsky, not that long before his death, and some other interesting people. Oh, and Rebecca Goldstein was on the panel also.
Yes. I also interviewed Rebecca.
Oh, did you?
Yeah, about Gödel's incompleteness theorem. My first question was, I believe, something like, tell me about Gödel's incompleteness theorems. And then she was like, oh, that's insightful of you to say theorems, because most people just think there's one.
Yeah, I think the first is more significant, at least for my work. But Rebecca in her book says something more important, that she considers Gödel a philosopher, not a mathematician.
Uh-huh.
He published very few papers because he only wanted to publish work that was philosophically significant. For a mathematician, his output was small, but for a philosopher, it wasn't. But he was a philosopher who he was very shy. He wanted to avoid controversies, and philosophy is only controversy, as I'm sure you've noticed with the different opinions on your podcast. A lot of his nicest essays were only published posthumously. He would do version after version, even correct the proofs, and not authorize being published. So Gödel only published philosophical papers for which he had mathematical proofs, and therefore there could be no argument about whether the result was correct or not. But you could still argue about what its meaning was, and people still do. Yeah, Rebecca has a nice book on Gödel's incompleteness theorem. I once was in a castle, in a schloss somewhere or other, at a small dinner with Rebecca's ex-husband. He's a physicist who's worked on Bohmian physics. That's physics with hidden variables.
Right.
Well, it's a personal joke. I shouldn't repeat it. So. But I actually rather liked Rebecca's book, not only her book on Gödel, little book on Gödel. She has a novel that I like called The Mind-Body Problem. She wrote a book about Spinoza, but it's not fiction. The Mind-Body Problem is fiction, Rebecca Goldstein. And that was, for a while, one test I would have with every young lady that I hoped might turn into a girlfriend. This was a long time ago. Would be to give the candidate a copy of Rebecca Goldstein's book and see what impression it made. This was, as you can imagine, not a good way to seduce or.
Well, it was a filtering mechanism for you.
Yeah, it was no good as a filtering mechanism, but I tried a few times. It never worked as I expected. She had a nice little biography of Spinoza. I thought, What makes it nice is it is short and non-technical. Ditto with Gödel.
To be clear for people who want to know the math, the Gödel sentence asserts its own unprovability in a consistent formal system. So it's written on screen here, and it basically means if this statement is true, then it asserts that it's not provable. So hence, it's not provable. And if it's false, well then the negation of it is true, and therefore it must be provable. However, it's asserting that the G sentence itself must be provable, thus we have inconsistency. Now, this fact, although seemingly obscure and arcane, is something that mathematicians, philosophers, and even physicists are still reeling from almost 100 years later. It means our formal knowledge will always be incomplete. There will always be facts out of reach by what even our most well-defined science can capture.
She did a number of works of fiction. The one that resonated with me was the mind-body problem, talking about the funny kinds of people who want to do fundamental research in math or in physics. But the problem with the mind-body problem is it deals with the mathematician who was precocious, was a child prodigy, and had done some great work. And somehow the magic stopped. The magic stopped. And he couldn't have any new ideas. And this sort of upset me, because I had some of my best ideas when I was a teenager. And I wondered, is this it? Is it over? Will I ever have another good idea in my life? And her book was very dramatic. This young lady who was interested in philosophy married this famous mathematician, only to discover that he considered himself a failure because since just before he married her, he hadn't had any new ideas from that point on, and it ruined their marriage, as you might imagine. So this is like a writer staring at a blank piece of paper, right? Or sitting at the typewriter. And so that's a problem with creativity. Magic has to strike. You wonder, will you get a new idea? And they don't come all the time, but I think I've been fairly lucky.
So in your case, did you feel like you've lost your creativity? Did no new ideas occur to you in your adulthood?
No, I don't think that's the case. As my wife Virginia points out, very often, even in public talks, I say, that's it. I pass the torch to you, young people. Go ahead. I don't think I'll come up with any new ideas. And that's not what happens, actually.
Do you think it's the case that as you age, that the amount of new novel ideas that are fruitful tend to become less and less? Or is it that you become a harsher critic, so just as many new ideas occur to you, but you shut them down in your own head, whereas when you were younger, you had the conviction to follow an idea, and even if you were older, if you were to follow one of those ideas that got hammered down, it would have produced something?
Yeah, well, what you're saying is pretty good. I think it's really a question. Of course, if you study too much and you get immersed in the current paradigm and you learn too much about it, then you're trapped. You become an expert in the current paradigm and then you're in a prison. But it's really a question of personality, it seems to me. The kind of person who goes against the current and comes up with new ideas, that personality is not going to change with age. You have to be unconventional. You have to not care what other people think and be willing to go out on a limb. I have my definition of genius. You see, to be a genius, you've got to be crazy. You've got to be crazy because you have to back a new idea at a time when there isn't enough evidence. If there were a lot of evidence, everybody would believe in it and it wouldn't be a new idea. So you're going out on a limb. You're all by yourself there. And if you're lucky, the new idea is correct and you're a genius. And if not, you're just a crazy person, an eccentric who didn't amount to anything. So I think I've been lucky. I think Stephen Wolfram has been lucky, but there are people who don't like the work we've done. The establishment doesn't like the work we've done. But I think no one can deny that Stephen and I are not following the fashion. We are doing a body of work that doesn't follow the fashion. And I think that's a good in itself, because I think we are an example that it is possible, even in our current very heavily controlled research environment, very bureaucratic, only concerned with money, progress reports, deliverables, milestones, grant requests, even in our current very inhospitable environment for creativity, it is possible you can't go be against the system, but you can sort of go outside the system, go around the system. Stephen did it by creating his own company. I mean, he's a genius that funds his research. Very few people can do that, obviously. And I did it by having a day job, which was, I was good at software engineering. And my night job, actually, it wasn't my night job, was fundamental research. IBM was happy to let me spend some of my time doing research if I was doing something useful for the company. Now, that was a period long ago, and I think now it's considered unacceptable that the stockholders will burn you alive if you let employees do that. But at that time, IBM was the computer company in the world, and they had the luxury of allowing some blue sky research, some done by their researchers. So when I was at the Watson Research Center, it was delightful. But I understand now that it's considered that everything has to be useful. And in fact, I think the way the research, I don't know, I haven't been in touch with them for a long time, but the way the research division was starting to operate when I left, when I retired from IBM, was that you had to get external funding for a project. In the days when IBM was very prosperous, the corporation paid for the whole budget of the research division, and we had a lot of freedom. It was a golden sandbox, as they used to call it. But at the end, to do a project, you had to find a product division that was willing to invest money, basically so that you would help them develop a new product, or maybe it was the U.S. government. Most of the money had to come from outside the corporation. And what that means is basically you're a hired gun. It's not curiosity-driven research. You're doing things, you're prostituting yourself, doing things that other people want for practical purposes instead of following your dreams or your curiosity, which is the best thing for doing research. Or, IBM Research had some people doing fundamental physics when I was there, totally blue sky basic research. But there were also people who were doing technology projects, which was great fun. I was on such a project. And it's great fun to create a new computer with a new operating system, new compiler, the whole thing from scratch. It's like having a child because it works. You can use it afterwards. But the problem then is selling it to the corporation, and a new product, a new kind of computer based on new ideas competes with the existing product line. And you can't predict how well it'll sell. And so people called IBM Research a golden sandbox because we came up with a new way of building a computer and new software, new everything. And the corporation really didn't want to pursue it as a product. But by paying us salaries and letting us do that, they made sure we didn't go to a startup that would have competed with IBM. There was a genius there who he would go around telling people his ideas for new computer architectures, just to make sure that his ideas weren't totally squelched. So innovation is a tough business, and you've got to be a little crazy to do it because you're fighting the system.
What if someone says, look, you can be outside the system and you can make a contribution, but that's no guarantee. It may not even be a necessary condition. It's certainly not sufficient. But let's say we think it's necessary. Then someone points out examples where, well, we have ADS CFT that came from inside.
What is that? I'm sorry, I'm not familiar with it.
From the holographic duality, ADS CFT.
Ah, yes.
Conformal field theory.
Well, that's very pretty, but it doesn't apply to this world.
Yes, right. The point is that it's an innovation, and it also has applications in condensed matter physics. That has implication in the real world. And then there's quantum computing and quantum error correcting codes. So those are inside the academy. And earlier, you argued that certain mathematical results may not have a direct application in our physical world, but they could be relevant in some, say, mathematical realm. And if we accept that as a premise, then the critique that, hey, it doesn't apply to the real world, that loses its force.
Well, that's a controversial topic, especially because I knew some of the people who created quantum computing. I regard that as technology, not as fundamental innovation. But it's true, the reformulation of quantum mechanics in terms of qubits, it's the same old quantum mechanics from the 1920s, but it feels and looks rather different when you do quantum mechanics in terms of qubits and quantum computing. So that has been, I agree, that has been something. But I want more than that, because you see, it's just a reformulation of 1920s quantum mechanics.
At this point, you may be wondering, like myself, why Greg continually puts the 1920s as the latest revolution in physics. I emailed Greg afterward, saying, "Dear Gregory, in our talk, you mentioned that the foundations haven't changed since the 1920s. However, in the 1950s, 60s, and 70s, there were significant developments, such as electroweak unification, confinement, and QED. Did you mean to say that there has been no new innovation since the 1970s? Greg then responded, and I have permission to use his voice here.
You have a right to disagree, of course, but seen from a vast distance, the basic quantum framework, the real revolution, was the 1920s. At least that's how I see it. To me, the topics you mention are just details. Best, Greg." It's just a reformulation of 1920s quantum mechanics. It's clothed in a different way, but there is no fundamentally new phenomenon there. You know, you want to poke reality and get it to squeak. It's not easy to find an experiment where nature shows some new phenomenon that you never imagined before. And then it's tough to convince people that the experiment isn't flawed, doesn't suffer from noise or other problems, and to get it published is tough if there isn't a theory that accounts for it. I agree. I'm a contrarian. I'm a romantic. I don't believe in big science, but there are things that big science has accomplished and that the current system has accomplished. And by the way, the person who did that work that you mentioned, whatever it was, I think he was in Argentina. Is it Maldacena or something?
Yes, right, exactly.
Who's now at the Institute for Advanced Studies. But he studied in the physics department, where I had friends long ago when I was teaching at the University of Buenos Aires many, many years ago. Another thing I don't like the system, it's like a giant prison, frankly. And young researchers they can't get married, they can't have children, they can't have new ideas, they have to keep publishing. They don't earn any money, they have to keep moving from institution to institution, constantly publishing papers, very often fairly trivial papers with only small incremental advances. I think that's ridiculous. Another aspect of the system is writing books doesn't count. Another thing is I knew a professor in Argentina. There was a professor who was a wonderful teacher of mathematics. The students loved him. He created a whole school, but he wasn't a researcher. He wrote beautiful books on the history of mathematics. So forcing everybody to constantly be publishing a stream of research papers is ridiculous. I think if somebody is a wonderful teacher, that's a contribution. And the current system, publish or perish, I think is ridiculous. And the result is that we're publishing a lot of trivial stuff, that it's not worth the trouble to try to read. I think small is beautiful, and there ought to be more freedom and more imagination. And they've taken the fun out of it. As Einstein said, about doing research, you have to do it from curiosity or from love. If you're forced to do research, it's like forcing a wolf to eat steak. Yes, a wolf is very hungry and loves steak, but if you keep constantly forcing the wolf to eat steak, it won't want. It's going to get sick of it. So this business of forcing people to produce a constant stream of relatively unimportant research, so they can't stop to change to change fields or to try anything really risky because it might lead to a hiccup in the stream of constant publications. I think this is all bad, and basically they've taken the fun out of it. What's the point? I wouldn't want to be a researcher in the current environment. I'm a rebel. I want to be creative. I want to have fun. If it's not fun, it means you shouldn't be doing it. Elon Musk says, why do you wake up in the morning? If it's just solving problems, but if you say, we're going to get to Mars, that's a challenge that can excite your imagination and make you feel it's worth something. But the current system, I don't know. I feel it's sort of gruesome. It's sort of like a prison, and I don't like it. But amazingly enough, some young people manage to do good work in this horrendous environment. I admire them greatly, but I couldn't do it, is all I can say.
Greg, do you have a way of differentiating which philosophers will give you insight into something mathematical or physical? So, for instance, Kant may give rise to something physical or mathematical, but it's less clear to me that Tolstoy has some claim on the Church-Turing thesis, for instance.
Well, Tolstoy doesn't.
Yes, right. So is there some way that you can look at Leibniz and say, okay, well, let me read the philosophy of Leibniz. That may inspire me mathematically.
Well, it did.
Yes, yeah. Is there some criteria that you have to a priori sort out which philosophers are more likely to give you ideas?
I resonate with fundamental new ideas. I was good as a young student. I had piles of books, and I wouldn't read the book from cover to cover. I could very quickly see if there was a new idea in it, or if it was more of the same, warmed up soup. So I have this feeling for when there's a gem there, a new idea. Now, you were talking about, this business of publish or perish shows how bad the current system is. Another thing that shows how rotten the current system is shut up and calculate.
Right. You said that was suicidal, and I'd like you to explain why.
Intellectually suicidal. Well, if you read about Einstein and his life, or you look at Schrödinger, Einstein, all these people, von Neumann, all these people knew philosophy. It was part of the German-speaking cultural world. They read philosophy, and just being good at doing meaningless calculations. I mean, yes, that's a talent, but you've got to think about what you're doing, and you've got to ask, is this the only way? Could there be another approach? Am I really asking the right question? For example, his reaction to the particle physics, the zoo of all the different particles, hundreds of particles, depends how you define particle, right? Some live very briefly. Mm-hmm. He said he just wanted to understand the electron, really understand the electron. The electron is problematical. It's a singularity, and it's problematical in classical physics, and it's problematical in quantum physics, because if the electron is a point, there's infinite energy in the field around the electron, according to classical Maxwellian electromagnetics. And in quantum mechanics also, it doesn't solve the problem, So there's also the question of if you say the electron is a little sphere, then it's going faster than the speed of light. It's rotating faster than the speed of light, it turns out. So if you say it's a point, you get into trouble. If you say it's a rotating sphere, there were things called Poincare forces having to do with electrons as spheres that didn't work out. So guess what? Physicists don't ask this question anymore because they know that nobody has an answer. So you ask the questions where it's safe, where you can do calculations that are meaningful, and you avoid the questions which give you infinities, series that don't converge. But technically, that means your theory is inconsistent or incomplete, right? So the way it works is you just don't ask the questions that get you in trouble. But those are the interesting questions, actually, the questions that get you in trouble, in my opinion. This is why Einstein just said, all I want to understand is the electron, really understand the electron. And he had no interest in the particle zoo, he called it. Now, Murray Gell-Mann had a completely different kind of mind from Einstein. I had the misfortune of meeting him, good fortune or misfortune. The first thing he does when you meet him is he tells you what language your name comes from and what it really means. You know, he knows dozens of languages. He has an encyclopedic mind, and this was the kind of mind that could deal with the particle zoo. So I had no idea where my name came from. I then went to my dad and said, is this correct, what he told me? And my dad said, yeah, as a matter of fact, actually it is. So it's a completely different kind of mind. Einstein was only interested in very deep questions. Deep question like, are physical objects continuous or are they discrete? And his own attitude to his own work was, well, it's all tentative, you know. It's all tentative. We'll see how much survives in the physics of the future. He didn't take it that seriously, you know. So when you make a religion out of the current theories, then you're never going to come up with a new theory. So it's important to break the rules, or to, how do you say, be an iconoclast. You have to be willing to do that to find something new. It could be that, you know, some people have been trying. They're saying there is no dark matter. It's the equations for gravity are wrong. That's a possibility, right? Modified, what is it, MOND, Newtonian dynamics, for example. There are different versions of this.
Correct.
You know, but they're all very ad hoc. And, you know, you ask yourself, how can they be justified? Now, there are ideas like the universe is built out of information, which are very provocative, and quantum, that I've believed in for a long time, as an interesting topic for research. And quantum information theory and quantum computation is a major step in that direction, in my opinion. But does that mean that all of physical reality is information? Is consciousness information? You know, I've tried to see how far I could take that point of view. So you've got to be willing to go out on a limb and try new ideas, but the funding agencies will never give you a grant for something.
What would be meant by consciousness as information?
Well, you can measure consciousness in terms of information, saying how much information are you conscious of? And so you can use measures of information as a way of measuring the amount of consciousness. I don't know. You know, there's a nice book by David Chalmers, The Conscious Mind is in Search of a Fundamental Theory. This was, maybe it's 20 years ago. And he has a whole chapter on information theory. I think that's a very provocative book. You know, maybe in 200 years we'll understand more about such topics, you know. But for now, they're pretty elusive. But if you just stick to stuff we know how to do, you're never going to find anything new. So one has to think out of the box, I think. It helps if you're independently wealthy, because if you've got to get research grants to survive and not starve to death, you're going to have to dance to the tune of the piper, right? You're not going to be able to do what you want. So the way Stephen Wolfram solved that is he made his own very successful company. So he can, now that the problem with that is I've known some people who've done that, but then they had no time left to do their research.
Right.
They said, I'm leaving academia. I'm going to make my own company and make money. And then I can do with that money all the research I want. Well, they managed to do the first step, but it's a full-time job. They never got back to doing research. Stephen is unusual in that he did get back to doing fundamental research.
Well, this can't be the solution for everyone.
No, it can't be.
So for the young person who's watching, who wants to go into the universities or wants to contribute something large, something innovative, what is the advice?
My advice would be follow your curiosity. Pay no attention to what's fashionable. You know, at the end of your life, you'll say, what did I do with my life? You tried and maybe succeeded a little bit in doing something new. If you just follow the current fashion, it doesn't matter whether you succeed or not. You've really accomplished very little, with your life. So it's a question of what do you find meaningful? I would tell them, fight the system, but you can't fight the system. It's bigger than we are, right? What you can try to do is ignore the system. So one way is to do your research as a hobby and, make pizzas or something as a living. Max Tegmark, I know, had a steady stream of sort of routine astrophysical papers, good papers, dealing with analyzing large quantities of astronomical data, good stuff. And then he had the papers that might have been closer to his heart, which were very speculative, like the question of a multiverse of all possible mathematical laws. That's an extreme multiverse. But he was doing a solid work. So you have to have enough energy to do both things at the same time. When you're young, it is possible. It is possible to do more routine work to survive, or be a computer programmer, or have some other way of earning a living, and then have your art. There are a lot of amateur musicians who are very good. Sometimes for a musician, it's very tough to survive financially. I knew one musician. He had various church choirs that he directed. He would tutor people who wanted piano classes. It's not easy when you go off in your own direction. But I think a life like that is, if you believe in Dharma, I don't know. Some of us feel a need to do this kind of thing. We don't want to be just cogs in the machine, or just like soldiers following orders. But it's tough. You have to be lucky to get away with it, right? And the fact that you're unconventional doesn't mean you're going to make great art or you're going to discover a new kind of physics. But at least you give it a try, And I think that is something that one can be proud of, that one gave it a shot, whether or not one succeeds. I mean, there is this old statement that if you have an unambitious research project, you may succeed and solve it, but so what? If you have an extremely ambitious research project, you may never solve it, but you're bound to find interesting things along the way.
Great. Professor, do you have any advice for myself? I have this channel here. I want to contribute to the field. I don't want it to just be where I'm speaking to someone and then passively some information is conveyed. And maybe there are some nuggets here and there that creep up from the conversation and that spurs some research. So that's already happened. A tiny modicum in your case with the extended evolutionary synthesis and Tim Maudlin, and there are a variety of other examples. But I want to actively contribute more to research using this, not just this podcast, but this whole channel, this whole project, this whole Theories of Everything project that I have. So what advice do you have?
Well, you're making a valuable contribution. People in the system can't even write books because you don't get credit for writing a book. You only get credit for writing refereed papers in high-impact journals. Writing a book is a hobby. People used to write books. Wonderful mathematicians and physicists used to write books. And nowadays you get no credit for it. You may do it anyway because you have nothing better to do, at the end of your career. Anyway, I think you're contributing because you're getting people to question the received wisdom, right? You are interviewing some unconventional people, not just the standard bearers. You're also interviewing them. Your survey of superstring theory, I'm sure was a lot of hard work, and it means you understand a lot of physics. And that's valuable too, because some young person may look at that and say, oh, this is superstring theory. Do I want to take the trouble to learn this and work in this area? Is this what excites me? It excites my imagination. Do I want to spend my life on this? And by giving them a overview of the whole field, which nobody does in an understandable way, you're helping young people to decide, what am I going to do with my life? You've got to make this decision. In my opinion, it helps to make the decisions, what am I going to do with my life, in high school, actually. Because that's after that, you start going, on the rails in different directions already. You have much less freedom. High school, Stephen and Wolfram and I were saying to each other, is maybe the last time that people still have open minds, and maybe it can be influenced. So I'm sure a lot of the people that look at your stuff are not established scientists. They know what they want to do. They know their area. They're not going to waste the time. So I suspect that the people who are looking at your podcast are younger people, outsiders, who, some of them are outsiders, but you have to be pretty interested to go through your thing on superstrength. You have to have a pretty great curiosity for physics. So I suspect that a lot of the people who are looking at your stuff are young people who are trying to decide what to do with their lives. What is the area that they feel they can contribute to, that they believe has some beauty or some that they resonate with for some reason, depending on their personality. People are born with personalities. And my two children, each one of them is very different from the other. So I was doing crazy research as a child already. And as a teenager, I was already coming up with definitions of randomness and stuff and complexity. So each person has different talents. And, as somebody said, you can't know if you like pea soup if you've never tried pea soup. So you're giving people a chance to see different things out there and maybe decide what to do with their lives. So I think that's a valuable contribution. And so I would say, keep it up if you can survive financially like this. So I think what you're doing is splendid, and it's going to help. It's going to help some young people to decide what they want to do with their lives, which is a very important decision, and you've got to make it as young as possible. So I would say, congratulations and keep up the good work, Kurt, is what I would say.
Professor, thank you for inviting me to the Institute for Advanced Studies. That was an honor, and it was great to see you in person and to meet Raphael and a slew of other wonderful people.
Thanks very much, Kurt. Take care.
Also, thank you to our partner, The Economist. Firstly, thank you for watching. Thank you for listening. There's now a website, kurtjaimungal.org, and that has a mailing list. The reason being that large platforms like YouTube, like Patreon, they can disable you for whatever reason, whenever they like. That's just part of the terms of service. Now, a direct mailing list ensures that I have an untrammeled communication with you. Plus, soon I'll be releasing a one-page PDF of my top 10 toes. It's not as Quentin Tarantino as it sounds like. Secondly, if you haven't subscribed or clicked that like button, now is the time to do so. Why? Because each subscribe, each like helps YouTube push this content to more people like yourself. Plus, it helps out Kurt directly, aka me. I also found out last year that external links count plenty toward the algorithm, which means that whenever you share on Twitter, say on Facebook or even on Reddit, etc., it shows YouTube, hey, people are talking about this content outside of YouTube, which in turn greatly aids the distribution on YouTube. Thirdly, there's a remarkably active Discord and subreddit for Theories of Everything, where people explicate toes, they disagree respectfully about theories, and build as a community our own toe. Links to both are in the description. Fourthly, you should know this podcast is on iTunes, it's on Spotify, it's on all of the audio platforms. All you have to do is type in Theories of Everything and you'll find it. Personally, I gained from rewatching lectures and podcasts. I also read in the comments that, hey, toe listeners also gain from replaying. So how about instead you re-listen on those platforms like iTunes, Spotify, Google Podcasts, whichever podcast catcher you use. And finally, if you'd like to support more conversations like this, more content like this, then do consider visiting patreon.com/kurtjaimungal and donating with whatever you like. There's also PayPal, there's also crypto, there's also just joining on YouTube. Again, keep in mind, it's support from the sponsors and you that allow me to work on Toe full time. You also get early access to ad-free episodes, whether it's audio or video. It's audio in the case of Patreon, video in the case of YouTube. For instance, this episode that you're listening to right now was released a few days earlier. Every dollar helps far more than you think. Either way, your viewership is generosity enough. Thank you so much.